Hello again, students. This video is to help you with the homework over operations with radicals. So we have radicals and we're going to add, we're going to subtract, we're going to multiply and divide with those radicals. But before we get to those operations, let's make sure that we are comfortable with breaking down radicals, whether those are square roots, cubed roots, fourth roots, or whatever. Let's just make sure that we understand what it means to take a radical or have a radical of an expression. So here we have the square root of 49x to the sixth. Okay. By the way, what I'm going to do is I'm going to go through the entire homework assignment. So our strategies should be the same for every question, although our numbers might be a little bit different. This will help you guide you through the entire this assignment. So here we have the square root of 49x to the sixth power. What I'm going to do is I'm going to break this down. Instead of writing this as the square root of 49, I'm going to rewrite 49 as prime factorization as 7 times 7, and then x to the 6, which really means x times itself 6 times. So 1, 2, 3, 4, 5, 6. Okay, so this is a square root. So the index isn't given, and so that means it's an implied 2. So that means that what it does is it's looking for a factor. So for example, 7's a factor. It's looking for 2 of them. And if you have 2 of them, then that means if you take the square root of that, the square root and the squaring will cancel out and you're just left with that factor. All right, so what I'm looking for, since my index is 2, is I'm looking for groups of 2. So here I have 2 7s, here I have 2 x's, here I have another 2 x's, and here I have another group of 2 x's. So I could write it like this, and you don't have to, but this is what this means. I have the square root of 7 squared times the square root of x squared for this group. For the second group of x's, I also have the square root of x squared. And then I have that another time. Oops, that's a multiplication symbol. And here I have the square root of x squared again. And square rooting and squaring cancel each other out. They're inverse operations. So all of these just cancel each other out. And so what I have is 7 times x times x times x, or that's going to be 7x to the third power. So here's my final answer. The square root of 49x to the sixth power simplifies. This was actually perfect squares underneath. And so that means the radical completely goes away, and I'm left with 7x to the third power. All right, let's take a look at question number 2. All right, so question number 2, very similar to question 1, just working with a little bit larger values. But once again, it is a square root. The index isn't given, so it's an implied 2. So we're taking the square root of 64, x to the 12th, y to the 26th. So hopefully we all know that the square root of 64, that is going to be 8. We could rewrite this as 8 times 8, and since we have 2 8s to give us the 64, that means that that's going to simplify to just be 8. But what about x to the 12th? I could do this strategy of writing out 12 x's and then circling how many pairs that I have. But hopefully you'd come to realize, since I have 12 of them and I'm looking for pairs, so how many groups of 2? 12 divided by 2 means that that's going to be 6. So that means I'm going to have x to the 6th power. All you need to do is take the exponent of your variable base and divide it by the index. So 12 divided by 2 means x to the 6th power. And then 26, that's for my y's. So 26 divided by 2 means I'm going to have y to the 13th. So my answer for number 2 would be 8x to the 6th, y to the 13th. Once again, perfect squares underneath the radical, which means the radical went away when I simplified. But number 3, that's not going to be the case. So let's look at question number 3. Okay, question number 3, once again, is a square root. But this time I have square root of 81m to the 11th. So I have the square root of 81, which is 9 times 9. So that is a perfect square. But m to the 11th, that's not going to be. If I were to write out m 11 times and look for groups of 2, that's not an even number, which means it's not going to work. So here's what I'm going to do with that. First thing I'm going to do is square root of 81. That's 9. M to the 11th, what I'm going to do, instead of having this as m to the 11th, I'm going to write this as m to the 10th times m to the 1st. It's your exponent rules with multiplication. Okay, what you're really doing are adding. So m to the 10th times m to the 1st is m to the 11th. Okay, so m to the 10th, if I'm taking the square root of that, it means I'm going to have m to the 5th power, because 10 divided by 2, I'd have 5 groups of 2 m's. Okay, so I have perfect squares, but what I don't have, m to the 1st, and then taking the square root of it, that's not going to simplify, which means that m, one of them, is going to stay underneath my radical. Okay, so my final answer is going to be 9m to the 5th, and then the square root of m. Now, it's very important to be careful on this. Okay, now when you type it in, you're going to have to make sure that you have this in the right spot. But if this was on a quiz or a test, make sure that you're careful. Make sure that your exponents don't start looking like the index of the radical. So if you want to squeeze in an index of the radical and make that a 2, that's fine. If you don't want to put that, that's fine as well. Just make sure that that 5 doesn't look like it's an index. All right, so when I type this in, I can type it in as either the square root, use this one, or I could choose this answer and then physically type in that the index is 2 and then put everything else that I had. So what was that? 2m to the 5th power. And then I would still have an m to the 1st underneath. So that should work. Or I could use the that square root button. Just be careful with your exponents not looking like an index. All right, so question number 4 is a little bit different because now we are getting into other types of radicals that aren't just square roots. So in this case, I have the cubed root of 16. Okay, so even though it's a cubed root, I'm going to go through a similar strategy. I'm going to break it down. And so I'm going to have the cubed root of, instead of having this as 16, if you need to do a factor tree off to the side, do a factor tree. But I know that 16 is 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay, so this time my index is 3, which means I'm not looking for groups of 2. I'm looking for groups of 3. So I have 3 2's. I'm going to circle those up. So what I could do is I could rewrite this as the cubed root of 2 to the 3rd power times the cubed root of 2 to the 1st power, or just 2. And a cubed root and cubing will cancel out, which means I'm left with 2 outside of a radical. But this doesn't work. I can't cancel a cubed root with 2 to the 1st power. So that means I'm going to be left with the cubed root of 2. So here my final answer would be 2 cubed root of 2. Okay, so just in case you don't know on how to type that into Math Excel, I'd come over here, I click on my box, and then these should pop up automatically. I'm looking for the nth root, and I'm going to type in that the index is 3, and I had a 2 outside of the radical, and then a 2 that remains underneath the radical. And so that's how I'm going to type in these roots that aren't just square roots. All right, question number 5, now we have the 4th root. So that means instead of looking for groups of 2, we're looking for groups of 3. Now we're looking for groups of 4 of these factors that we have underneath the radical. So first thing that I'll do is I'll just take whatever is underneath and break it down. So 810. Yeah, this one I'm going to need a factor tree for. So 810, that's going to be 10 times 81. And 10 is going to be 2 times 5. And 81 is going to be 9 times 9. And 9 is 3 times 3. Okay, so all of these are prime numbers. What it means to be a prime number is it's divisible by itself as well as 1. So 1's not a prime number because it's only divisible by 1. But 2 is a prime number, 3 is a prime number, 5 is a prime number, and so on. So the only even prime number that we have is 2. Everything else is going to be odd. And so 2, 5, 3, 3, 3. If I multiply all this out, 2 times 5 times 3 times 3 times 3 times 3, I should get 810. Okay, and so what I'm going to do now is I'm going to rewrite this as the 4th root of 2 times 3 times 3 times 3 times 3 times 5. And I'm looking for groups of 4. So I have 4 3's right here. So I'm going to group them all together. If I wanted to, I could write it like this, but you don't have to do this. I could rewrite this as the fourth root of 2 times the fourth root of 3 to the fourth times the fourth root of 5. So the fourth root of 3 to the fourth inverse operations will cancel each other out. So 3 is the only factor that escapes and comes to the outside of the radical. And so what I have underneath the fourth root still is 2 and a 5, and we're multiplying, so 2 times 5, that's going to give me 10. So here would be my final answer, 3, and then the fourth root of 10. Okay, question number 6, back to a cubed root, or at least I am. So a cubed root, I'm looking for groups of 3. So I'm going to take the number 108, and I'm going to break that down. So I know that that's going to be 2 times 54. And then 54 is 6 times 9, and 6 is 2 times 3, and 9 is 3 times 3. Okay, so I have my prime factors. So I'm going to rewrite this as the cubed root of 2 times 2 times 3 times 3 times 3. And then, since this is a variable, instead of writing it as x to the 8th, remember I'm going to take that exponent and divide it by the index. So 8 divided by 3, but that doesn't work, okay, because 8 isn't a multiple of 3. But what I could do is I could rewrite this as x to the 6th times x to the 2nd, because product rule says 6 plus 2 is 8. So x to the 6th times x squared means that I have x to the 8th power. But the reason why I did this is because I chose the highest multiple of 6 that is in 8. So x to the 6th, that'll be able to break down, and then I'll have my leftover portion right here. Okay, so I'm looking for groups of 3. So this is going to break down. I have 3 3s, and then x to the 6th. Again, that's a multiple of 3, so that's going to break down as well. Everything else is going to have to remain underneath the cubed root. All right, so what I have is going to be 3x to the 2nd. Okay, so I have one group of 3 3s. Okay, and then x to the 6th. 6 divided by 3 is 2, so I'm going to have x to the 2nd. And then I'm going to have the cubed root of 2 times 2, which is 4. And then I also have x squared. So my final answer is 3x squared times the cubed root of 4x squared. So again, when you're typing that in, I'm just going to have to be very careful that I'm going to have 3x squared, and then I'm going to have the cubed root. Okay, so be very careful with your exponents and with your index, and then you're going to type in whatever it was that you have left. Okay. Whoops, and don't do what I just did. I lost my space, so then I typed it in, and it was underneath the radical. There we go. So now it's underneath the radical. Now it should work. All right, question number 7. Now we're going to start getting into these operations. So we're going to add, we're going to subtract, we're going to multiply and divide. So first we're going to start off by adding and subtracting. And so the way that it works with radicals is, even though these aren't variables, they're kind of treated like variables when it comes to like terms. So you're looking for the exact same radical. So that means the same index and the same radicand. So you're looking for what's underneath the radical to be the same as well. So 4 square roots of 3. So this is saying we have 4 of these square roots of 3s plus 7 square roots of 3s, which means that we're going to have 11 total. 4 plus 7 means we're going to have 11 of these square roots of 3. All right, I think that's easy enough that we don't need to show any work on question number 7. But adding and subtracting with radicals, very similar to just adding and subtracting with your variables and looking for like terms. Okay, but now number 8 has gotten a little bit trickier because I have square root of 12 plus square root of 108. And so your intuition would be like, okay, there's 1 square root of 12, there's 1 square root of 108. Those aren't like terms, I can't combine them. But they're going to trick you on these. First thing that you need to do is make sure that the radicals are as simplified as possible. That's why we started off with the simplifying radicals first. Okay, so here we have square root of 12 plus the square root of 108. Okay, so right now it doesn't look like these are like terms. They're both square roots, but they don't have the same number underneath the radical. So you'd think that they're not like terms. However, I need to simplify first. So the square root of 12, I can rewrite this as the square root of 2 times 2 times 3. And there's a group of two twos, and the index is 2. So this is the same thing as 2 square root of 3 plus the square root of 108. Well, that's convenient. I don't know if it will be for you, but mine's the same as my number 6. So I already have the breakdown. It's 2 times 2 times 3 times 3 times 3. You might need to do your prime factorization off to the side. But the square root of 108, I'm looking for groups of 2. So I have 2 2's. I have a group of 2 3's. So 2 is on the outside, 3 is on the outside. So 2 times 3, that's going to give me 6. And then I have a square root of 3 left over. All right, so after breaking down these radicals, it actually turns out that these are like terms. This is saying I have 2 square roots of 3 plus 6 square roots of 3's. So that means I'm going to have 8 square roots of 3's. 2 plus 6 gives me the 8, and then keep the square root of 3. All right, so question number 9 now has 3 radical terms. And on first look, it looks like none of them are like terms. Square root of 8, square root of 72, square root of 2. Okay, square root of 2 can't be simplified since 2 is a prime number, but square root of 8 and square root of 72, those aren't prime, so I need to try to simplify if I can. So square root of 8, I can rewrite that to be the square root of 2 times 2 times 2, looking for a group of 2's. And I have 2 2's. That means I'm going to have 2 square root of 2 when I simplify the square root of 8. And then I have plus square root of 72. I can rewrite that as 8 times 9. And 8 is 2 times 2 times 2. 9 is 3 times 3. So again, I'm looking for groups of 2. So here are 2 2's. Here are 2 3's. So 2 and a 3 would come to the outside. So 2 times 3 is going to give me 6 on the outside. And what I didn't have circled was just a 2. So that means that square root of 2 stays. And then I have minus square root of 2. All right, so actually it turns out that all 3 of them are like terms. Sometimes that's the case, sometimes it's not. But since they are all square roots and they have that same number underneath the radical, they have the same radicands, that means that these are all like terms. So here I have 2 of them, here I have 6 of them, and then here I'm subtracting 1. So 2 plus the 6 would give me 8, minus 1 means that I have 7 of these square roots of 2. So here would be my final answer for number 9. Now, question number 10, we're going to move into the next operation of multiplication. So with the multiplication, in order to be able to multiply, you're not looking for like terms. All you need to have in order to be able to multiply is the same index of a radical. And then just always remember out times out, under times under. So in this case, I have square root times a square root. So I'm just going to take whatever is underneath this radical times whatever is underneath this radical. Now, you can simplify and then multiply, or you can multiply and then simplify. The choice is up to yours. The choice is up to you. It's whatever you prefer. So if I do the 7 times 12, if I choose to multiply first, what this is going to give me is underneath one radical, it's going to be 7 times 12. And I could get a calculator and multiply that out. That's 84. But my goal is to break it down. So why do that to myself? Why actually multiply it out and then break it down? Why not break down these smaller factors? So 7's a prime number, but 12 isn't. I can rewrite 12 as 2 times 2 times 3. So 12 is 2 times 2 times 3, and then times 7. Okay, so that's what I have for my numbers. And then my variables, I have x to the 7th times x to the 4th, which means I'm going to have x to the 11th. Now, I can either write that as x to the 11th, because 7 plus 4 is going to give me the 11, or I can already know that 11, since I'm looking for groups of 2, since this is an index of 2, I know that I'm going to want to rewrite that as something to an even exponent, because an even number is always divisible by 2. So I'm going to rewrite this as x to the 10th times x to the 1st. So another way of writing x to the 11th, but I did so in the fact that now I have this perfect square. All right, now I'm looking for groups of 2. I have 2 2's, 3 and 7, nope, can't do anything with that. And then this x to the 10th can break down. So what's outside of the radical is going to be a 2 from this group of two 2's. And then x to the 10th, taking the square root, is going to give me x to the 5th. And then I'll have the square root of 3 times 7, which is 21, and then x to the 1st, which is x. So my final answer is going to be 2x to the 5th power times the square root of 27x. Whoops. And as I was typing that in, I'm like, whoop, 3 times 7 is not 27. That is going to be 21. So let's try that again. All right, question number 11. Again, we're multiplying, but this time we're using the distributive property because we're taking a monomial times this binomial, one radical times two radicals. Now, if I work inside the parentheses first, following order of operations, square root of 3, that's simplified, square root of 21, I could rewrite that as the square root of 3 times 7, but that doesn't break down any. So I can't take the square root of 3 plus the square root of 21. That doesn't work. So all I can do with this is use my distributive property. And I am allowed to multiply because these are all square roots. Okay, so they don't have to have the same values underneath the radicals to multiply. They just have to have the same index. But in order to add or subtract, they have to have the same index as well as the same value underneath the radicals. Okay, so using the distributive property, I'm going to have the square root of 3 times the square root of 3, which is going to give me the square root of 3 times 3. And then I have plus the square root. I have this 3, I have this 3, and this 7. So it's going to be 3 times 3 times 7. And then now breaking anything down that I can. So square root means an index of 2. I'm looking for pairs. Here is a pair of 3's. This is going to be just 3. And then plus, here I have a pair of 3's. So this is going to be 3, but then I still have the square root of 7 that's going to be attached. So my final answer is going to be 3 plus 3 square root of 7. Okay, question number 12. I have 3 plus the square root of 2. Unlike terms, can't combine those, but I'm taking this quantity and squaring it. So what I'm going to do first is get rid of the square and just rewrite this as 3 plus the square root of 2. So I'm just multiplying this value times itself. Okay, so instead of distributing, I am still distributing. It's just I'm going to have to do it 2 times rather than just once. So first I'm going to start off by taking this 3 and I'm going to distribute that into the second set of parentheses. So I'm going to have 3 times 3, which is going to give me 9. And then 3 times the square root of 2. Here's a case where I have a number that's not under a radical, and here's a number that is under a radical. So they don't get multiplied together. The best thing that I can do, the only thing that I can do, is just put the 3 on the outside and attach the square root of 2 to it. All right, and then now that I've distributed that, now I'm going to distribute the square root of 2. So square root of 2 times 3, again, I can't actually multiply those together, so that's going to be positive, and then 3's on the outside, and then square root of 2. And then positive times a positive is a positive, and then I have the square root of 2 times 2. So I have a pair of 2's. So that's going to give me, 2, and then I had the 9 out in front. And then I have 3 square root of 2 plus 3 square root of 2. Last thing to do is look for any like terms. So 9 and 2, those are just constants. So I can combine those. 9 plus 2 is going to give me the 11. And then this is 3 square roots of 2 plus 3 square roots of 2, which means that I have 6 square roots of 2. So my final answer for number 12 would be 11 plus 6 square root of 2. Okay, question number 13, some more of the double distribution. However, on question 13, I hope you recognize that we have conjugates. 5 minus the square root of 5 times 5 plus the square root of 5. These are conjugates, which means that when I go through and I multiply these, my radicals are going to get rid of each other. So I'm not going to have any radicals whenever you multiply conjugates. If you had imaginary numbers, if you have radicals, those go away. And it just takes you back to a real whole number. Okay, so when I do this, I'm going to take 5 times 5. So that's going to give me 25. And then I'm going to take 5 times square root of 5, which is going to give me positive. A positive times a positive is a positive. And then 5 square root of 5 can't multiply, so I just put them together. And then I have negative square root of 5 times 5. So that's going to be negative 5 square root of 5. And then negative square root of 5 times positive square root of 5. Negative times positive is negative. And then square root of 5 times square root of 5 is the square root of 25, or square root of 5 times 5, however you prefer to think of it. All right, so here I'm going to have 25, and then 5 square root of 5 minus 5 square roots of 5. So here I have 5 of them. I'm subtracting 5 of them. These are going to cancel each other out. And then I have minus, and then the square root of 25, or the square root of 5 times 5, that's 5. So 25 minus 5, my final answer. Because these were conjugates, the radicals disappear on number 13, and you should just have a whole number as your answer. Question number 14. Once again, double distribution, but this time it's going to be just a little bit trickier because we have some values that aren't under radicals, and I don't think we've seen that yet. Okay, so I'm going to go through like normal. I'm going to take the 2 and I'm going to distribute that. So 2 times 8 is 16. And then 2 times 3 square roots of 5. Okay, so remember, out times out, under times under. So 2 is outside of a radical, 3 is outside of a radical. So 2 times the 3 gets multiplied together. 2 times 3 is 6. And then the square root of 5 just has to get attached because it was attached to the 3. Okay, now I'm going to distribute the minus 8 square root of 5. So negative 8 square root of 5 times positive 8. Negative times a positive is a negative. And then 8's not under a radical. This 8's not under a radical, so I multiply them. So 8 times 8 is 64. And then I attach the square root of 5. Okay, now the last one. Negative 8 square root of 5 times positive 3 square root of 5. So a negative times a positive is a negative. And then remember, out times out, under times under. So outside the radical is 8, outside the radical is 3. So 8 times 3 is 24. And then underneath the radical, both of these are radicals. So underneath those square roots, I have 5 and 5. So I'm going to multiply 5 times 5. Okay, now I need to go through and simplify and break things down. So 16, and then this is 6 square roots of 5. This is 64 6 square roots of 5, and that's a negative. But they're both square roots of 5. Okay, so it's telling us how many of those we have. So 6 minus the 64, that's going to give us the negative 58, and then square roots of 5. And then negative 24. And then 5 times 5, that's 2 of them. And I'm looking for 2 of them because it's an index of 2. Square root of 25, that's 5. Okay, so I'm going to have 24 times 5, which is 120. So really this is 16 minus 58 square roots of 5 minus 120. I combine the constants now. So 16 minus the 120, which is going to give me negative 104, and then minus 58 square roots of 5. Okay, so this would be my final answer. Negative 104 minus 58 square roots of 5. Okay, last of the multiplication. Save the hardest for last. Same strategy. The only reason why I'm saying it's saving the hardest for last is because every single one of these I'm noticing has radicals. It's okay. We know out times out, under times under. So I'm going to start off by distributing 8 square root of 5 times the second set of parentheses. Okay, so if you want to, maybe to make it a little bit easier, I will write it down. So 8 square root of 5 times 4 square root of 5 plus 3 square root of 6. And then I'm going to take negative 5 square root of 6 and multiply that through into the 4 square root of 5 plus 3 square root of 6. All right, so out times out, under times under. So 8 times 4, that's going to give me 32. And then square root of 5 times square root of 5, that's going to be the square root of 5 times 5. And then I'm going to take 8 square root of 5 times the second radical in this parentheses. So 8 times 3, outside numbers, 8 times 3 is going to give me 24. And then square root of 5 times square root of 6 is going to give me the square root of, now I like to do it this way, is breaking it down. 6 is 2 times 3 and then times 5. Okay, so I didn't really need to write it that way. I like to just to make sure that I don't have any pairs of anything. But that one's not going to break down at all. Okay, now I need to do my second distribution. This is double distribution. So now I'm going to take negative 5 square root of 6 times 4 square root of 5. So negative 5 times 4, which is going to give me negative 20. And then under the radicals, I'm going to have square root of 6 times 5, which is just going to be the square root of 30. We already know that doesn't break down. And then I'm going to distribute again. And negative 5 times positive 3 is negative 15. And then the square root of 6 times the square root of 6 is going to be the square root of 6 times 6. Okay, so looking for anything that can break down. Okay, so this is going to be 32 times 5. 32 times 5, which is going to give me 160. And then plus, this is 24 square roots of 30. And then this is minus 20 square roots of 30. And then this is going to be a minus, and then 15 times 6, which is going to give me 90. So combining the like terms, I'm going to have the 160 minus the 90, which is going to give me 70. And then 24 square roots of 30 minus 20 square roots of 30. So 24 minus 20 is going to give me positive 4 square roots of 30. So here would be my final answer, 70 plus 4 square roots of 30. So not the hardest, okay, not the most fun by any means, not the hardest either. Nothing about this lesson should be too difficult. We're just making sure that you really understand what the radicals means and what we are allowed to do when it comes to radicals. All right, so we have one more operation to go, and that's going to be division. All right, so here I have question 16. I'm working with division, and it's just the same as multiplication. In order to be able to multiply, in order to be able to divide, the only rule is that they have to have the same index in that radical. Right, so here I'm looking at the 6th root, and I'm looking at the 6th root. I could try to simplify the 6th root of 12x to the 5th before I started, or I can go ahead and do the division first and then try to simplify there. All right, so since I'm working on dividing here, since these are both under the 6th root radical, okay, that means that I can. And so I'm just going to divide the whole numbers, and then I'm going to divide any of the common bases, and then simplify anything that I have remaining. All right, so I have the square root of 12, or not the square root, I have the 6th root of 12 divided by the 6th root of 2. So 12 divided by 2 is 6, and then I'm just going to keep it underneath the 6th root. So 12 divided by 2 is 6. Larger number was on top, so that means I don't have the fraction anymore. So 12 divided by 2 there. And then x to the 5th over x to the 4th. Remember, your quotient rule means that with exponents, you really subtract. Here you'd have 5 x's, 4 on bottom. That means that 4 of them would cancel. You'd be left with x to the 1st. And then you try to break this down if you can, but 6 is just 2 times 3, and you're looking for groups of 6. So my final answer here is just the 6th root of 6x. All right, question number 17. I have the square root of 500 divided by square root of 5. So I'm allowed to do this because I have a square root and a square root. So that means I'm allowed to multiply. In this case, I'm also allowed to divide. So what I'm going to do is I'm going to keep the square root, and I'm just going to do the division of what's underneath. So 500 divided by 5 is 100. And then always try to simplify it if you can, and the square root of 100 simplifies down to be just 10. So my final answer for 17 would be just the answer of 10. All right, question 18, another division. Both of these are square roots, so I'm allowed to divide. So what I'm going to start off with is just taking the 54 divided by the 3, which is going to give me 18. So I'm going to keep the square root symbol. 54 divided by 3 gives me the 18. And then x to the 7th divided by x to the 6th. 7 minus 6 is 1, so that's x to the 1st. And then y to the 9th divided by y to the 7th. 9 minus 7 is 2, so that's going to be y to the 2nd power. Rewriting this, I could write this as the square root of 2 times 9, which is 2 times 3 times 3, and then times x times y times y. And then since it's a square root, I'm looking for groups of 2. So here's 2 3s, here are 2 y's. So a 3 and a y come to the outside of the radical, and then I'm left with the square root of 2x. So my final answer is 3y square root of 2x. Okay, question number 19. I have the square root of 11 over 36. So 11 over 36, I can't do anything with that fraction, but what I can do is, since I'm taking the square root of this, I can think of this differently. I can take the square root of the numerator and then over the square root of the denominator. Okay, so because it's the same index, now I still have the same index, I would be able to write these equivalent expressions right here. Okay, now the reason why I did this is because 11 over 36 doesn't simplify, and neither does the square root of 11, but the square root of 36 does. I can rewrite this as the square root of 11 over the square root of 6 times 6. And since I'm looking at index of 2, I'm looking for a pair. I have a pair of 6s, so my final answer for this one's going to be the square root of 11 all over 6. All right, last question, another division. I have a square root on top, square root on bottom, so I'm allowed to divide with these. And just like with multiplying, out times out, under times under, same thing here, but it's going to be out divided by out and under divided by under. All right, so I have 21 divided by 7. That's just going to give me a good old 3. And then the square root of 14 divided by square root of 2. I'm going to keep the square root, and then 14 divided by 2 is going to give me 7. I try to break down that radical if I can, but since that's a prime number, I know my final answer is 3 square root of 7, and that's it. Okay, so I hope this video helped. It should have. Thank you for watching this to the end. Radical operations, just important to know. Again, this year is just learning the foundations for those upper level math classes. So it's good to know how radicals work because we're going to keep working with them. All right, thanks for watching. Have a good day.